Okay, so I happen to be in the office today, and I got some questions on one of the last questions on your homework that's due this upcoming week. So I figured I may as well just make a video while I'm here, just doing a little bit of extra work. So let me just kind of help maybe push you in the right direction here. Okay, so I think there's two parts maybe that I signed. Maybe I can't remember, but nonetheless, at least let's talk about this first part here. So let f be a function that maps a to b, and x is going to be a subset of a. So x is a subset of our domain. Okay, so this is what we want to try to prove. We want to prove that x is an element, or x is a subset of the inverse image of the image of x. Okay, so the very first thing we have to do is just convince ourselves that this is even true to begin with. So let's take a look at an example, one that we somewhat looked at in class. So if we just have the function that maps the reals to the reals, where f of x is given by x squared, and let's consider the set. So this capital X, this would be the same thing as over here. It's a set in our domain. Let's take a look to see what is happening with this when it goes through this process. So if we look at f of this I'll just say this to indicate a capital X to clarify things. So the image of this set is the image of the set containing 1. Right, so this right here, this is the set containing 1, so I'm trying to figure out where does 1 get mapped to with our function. Well, obviously it's given by x squared, so this is just simply the set containing 1. Okay, not too bad, but then if I want to take the inverse image of f of this, so now if I want to go and figure out if this is in my codomain, what elements get mapped to this? Well, I'm looking at the inverse image of the set containing 1. So I'm figuring out what are all of the elements in my domain that get mapped to 1. Well, there are 2 of them, both 1 and -1. So notice this is now an example of one that shows you that the opposite direction is not true, right? But this direction is true. So when we think about this process, when we do the image, right, we're pushing all of these elements from our domain into the codomain. But then when it goes in the opposite direction, we might pick up some new guys, right? So if we want to just kind of visualize this in terms of sets here, so let's say, for instance, this is the set X. Then when I map the image to this, there's some type of thing here, f of capital X, right? So this is the image of this set, but then what we're doing is I'm now going backwards to this. And so when we go backwards, we now pick up a slightly larger set, f inverse of f of x. So this is what you're trying to prove is true, that by coming back, we always, we don't have to guarantee that we pick up new elements. These could be equal to each other if you have a bijective function, which I guess if you watch the videos of this upcoming week, you'll know what that is. But nonetheless, so this at least, this might pick up new elements, but at least all of these original elements must still be in the set. So that's what you're trying to prove. So first convince yourself that it's true. Now to prove this, it's a surprisingly short proof once you start working through the definitions of it. So again, just to kind of push you in the right direction here. So your proof, what you're going to say is we can say let y be an element of x. Then what does that mean? So if you have y as an element of x, basically you're kind of imagining you're taking y, and now y is going to go on a trip. Y is going to be like, okay, what happens if we then apply the function to it, and then we look back at the inverse image of that. So that's the idea behind this, is you want to figure out what happens with f of y. What about this guy? Because we know that this must be assigned somebody over here in our codomain. So let the definitions of image and inverse image now push you in the right direction. And I'll also, after the homework submitted, I will just give you kind of the cleanest proof of this in case you're still not sure how to get it done. So hopefully that helps. If you have more questions on it, please let me know. But hopefully that gives you a little push in the right direction.